Okay, the displacement of x of a particle varies with time t is given by x equal to 4 cosine 2 pi t plus pi over 2, where x is in centimeter and time is in second. Calculate the frequency and the rest. Okay, so first of all, if you look at the equation of, what is the equation? This is a displacement equation, yeah, displacement with time equation. Displacement with time equation. So this, we are given displacement with time equation. Okay, and one thing to note about the unit is centimeter and second. So be careful, it is centimeter, not meter. Yeah, be careful with the unit. Okay, be careful with the unit. Time is in second. Okay, if you look at this formula, it's a little bit different from what we have learned from our syllabus. Our syllabus, look at this, our syllabus. Our equation displacement is sine, isn't it? A sine omega t. A sine omega t. X equal to A sine omega t. However, this equation is cosine. And some more it has plus phi. Plus the phi. But our syllabus don't have plus phi. So be careful. Sometimes the questions in the exam also will come out like this. But this one mostly we still can differentiate this equation no matter what. Okay, so don't be afraid to do this question because you still can differentiate. So we just change a bit. Yeah, the sine become cosine, and then we just add the plus phi behind. Okay, so what is the general equation for this one? Let me write it down. Yeah. So the general equation, okay, maybe I should write below. Okay, I rewrite this equation below here. X equal to 4 cosine 2 pi t plus pi over 2. Okay, actually this equation is according to general equation is 4 this is 4 is the amplitude, cosine, and then this is omega t, and then plus phi. Okay, this is how we compare. The 4 is the amplitude, the 2 pi is the omega, the pi over 2 is the phi, initial phase angle, or the phase constant. Okay, very simple. And the unit centimeter, x is centimeter. So when x is in centimeter, displacement is centimeter, the amplitude also centimeter. Okay, the amplitude must be also centimeter, and the time is in second. So the omega is in per second. Okay, now we can find the frequency of the motion. So frequency is f. So how to find frequency? All right, let us do it. Okay, frequency, we have the omega, isn't it? Omega is 2 pi. Yeah, omega is 2 pi. Yeah, just compare with the one above. Just compare to the above. Okay, so omega is 2 pi. So the equation for omega is actually 2 pi f. Okay, so they can cancel. And then what is the frequency? Frequency is 1 hertz, or 1 per second. 1 per second. So either unit, yeah, hertz or per second, because the time given is in second. So our frequency is per second, or hertz. So is the question okay, the answer is correct. Now how about the B? we want to find the velocity velocity at this time, velocity at this given time. Yeah, so we need velocity versus time equation, velocity versus time. And then the following question also acceleration at this time. So this one we need the acceleration versus time equation. And then the question D, he asked for velocity at this position, at this displacement from equilibrium position. So this one we need velocity displacement equation. So we need these three equations. Okay, to solve. Yeah, give you time, you use the time equation. Give you displacement, use the displacement equation. Okay. So B, I need the velocity time equation. So this one I need to differentiate. Excuse me. I need to differentiate the displacement equation in order to get the velocity time equation. Excuse me. Okay. I need to differentiate the displacement equation. So velocity is actually dx over dt. Differentiate the displacement versus time. Okay, this is the displacement versus time equation. Okay, differentiate. First of all, we differentiate outside. Differentiate the 4. I still get 4. Differentiate cosine, I get negative sign, isn't it? I get negative sign. So differentiate outside. Differentiate for cos, I get negative for sine. I differentiate cos, I get differentiate cos. Remember this thing. Differentiate. This one is differentiate with versus u. Differentiate when you differentiate with the sine, you get cosine. When you differentiate differentiate the cosine, you get negative sine. Remember this. Okay, differentiate sine, get cos. Differentiate cos, you get negative sine. So I differentiate the cos, I get negative sine. And then inside, I just rewrite again. This one is all differentiation. You need to know this mathematics. Okay, the inside, we just rewrite. We don't differentiate yet. And then we differentiate inside. What do we get? Differentiate inside versus time. This one is a constant. Pi over 2 is a constant, so it just disappear. Differentiate 2 pi t versus time. Differentiate 2 pi t over t. I get 2 pi. This one I get 2 pi, multiply 2 pi. Okay. So in the end, I get negative 4 times 2, get 8. So you know this one, just multiply to the front. Okay, to the front, I get all right, that's why I get negative 8 pi sine 2 pi p plus pi over 2. Okay, I did taught you about this differentiation last time. Okay, if you still remember this one. Okay, how I differentiate displacement to velocity and then to acceleration. The omega multiplied to the front is the same thing like this one. Yeah, this is actually the omega. Understand or not? This is actually the, you know, this is the A and this is the omega, and then omega multiplied to the front. That's why here we have A omega. Understand or not? And this A omega is actually the maximum. Is actually the maximum velocity. is actually the maximum velocity. This is the A omega. Okay. So we got the velocity equation already. This is the velocity equation. Remember, don't just write the equation. You must also give the unit. What's the unit? Let me write it down. Yeah. Okay. So where the V is in, the velocity is in centimeter per second, time in second. So okay. Why centimeter per second, not meter per second? Because it follows the displacement. Displacement also, displacement is centimeter. So that's why the velocity also centimeter per second. Okay. You must give the unit. Okay, not just the equation. So this 8 pi also in centimeter per second. Okay, now I can find the velocity already at this time. So let's find out. Okay, so what you do is you just substitute the time. You just substitute this time 2 seconds. You just substitute the time here with 2 seconds, and make sure this whole thing, make sure you put in radian. Make sure all this in radian. Understand not? All this in radian, not degree. Not degree. Substitute the time. So this actually this is the velocity versus time equation lah. So I can substitute the time with 2 seconds. Then I can solve. I can find the velocity. So now I straight away write down the velocity. Okay, I get the answer is still negative. Okay, I still get the answer is a negative value, negative 8 pi. I still get 8 pi. Okay, and which is negative 25.13. What's the unit? Velocity is centimeter per second because it's follow the displacement centimeter. Okay, answer correct? Yes, it is correct. Negative 25.13. So negative means it's moving down. Yeah, it's moving down. Okay. All right. So that is the velocity at 2 seconds. Okay. That is the velocity at 2 seconds. Okay, velocity at 2 seconds. So okay. So this you just use the velocity time equation to find. Now, how about acceleration? Acceleration, I need to differentiate again. So this time I differentiate the velocity time equation. I use the velocity time equation to differentiate versus time. Again, I differentiate the second time. So okay. So first of all, I differentiate outside. I differentiate sine, I get cos. Remember that? Differentiate sine, get cos. So differentiate sine, you get cos. And then the rest is the same. Negative 8 pi, differentiate sine, get cos. Okay. And then rewrite the inside. Rewrite. Okay, and then differentiate outside. I get negative 8 pi cos. Okay, and then differentiate inside, I get 2 pi. This one, if I were to disappear, differentiate 2 pi t, I get 2 pi. Okay. So yeah. So this again. As before, this one is last time this is omega and this is omega actually, and this omega multiplied to the front, and that's why we have, what do we have? we have negative 16 pi square cosine 2 pi t plus pi over 2. So this is actually a omega square. This part is the a omega square. Understand or not? This is the 16 pi square. 16 pi square is the a omega square. Omega multiplied to the front, you get a omega square. Okay, and in fact, this is the maximum acceleration. Maximum acceleration. Okay. So to find the maximum acceleration, you just take a omega square, or just take the value here, 16 pi square. And this is the a max. Okay, now I want to find the acceleration at 2 seconds. So I substitute the time. So now I already have acceleration versus time equation. What I need to do now is I substitute the time with 2 seconds. You must write the unit also. Be careful, you must write the unit. Okay, let me write down. Okay. Yeah, you must write the unit. Be careful with the unit. This is acceleration. This is centimeter per second square. Follow the displacement. And don't just write the equation, you must write the unit also. Now, so now you substitute the time with 2 seconds. So at time equal to 2 seconds. Actually, I need to write here. At time equal to 2 seconds. Understand? At time equal to 2 seconds, velocity is this. How about acceleration? At time 2 seconds, I substitute time with 2 seconds. And what is the acceleration? What is the acceleration? I substitute this one with 2 seconds. Remember, this one must be in radian. Yeah, remember this one must be in radian. All this thing. Same like before. Yeah. All this must be in radian. Okay. Let's calculate. Substitute with 2 seconds. Oh, I got the answer. Acceleration becomes 0. I get 0. What's the unit? Unit is centimeter. Write down the unit. The unit is acceleration is centimeter per second square and time in second. So the unit is centimeter per second square. The unit. This is the acceleration at 2 seconds. Okay, is the answer correct? Yes, it's 0 centimeter per second square. That's correct. Okay, this one also correct. Okay, remember this one must be in radian. Now, want to do the question D. Question D. Question D. Okay. So this is question C just now. Question C. Now question D. Okay, question D. So question D, what is the velocity at this displacement? Now I give you displacement to find velocity. This one you need to use velocity displacement equation. Velocity displacement equation. What's the equation? What's the equation for velocity displacement? Velocity displacement equation is this one. Yeah, velocity displacement equation. Velocity displacement equation is plus minus omega a square minus x square, square root a square minus x square. So use this equation. Okay, so v equal to plus minus omega a square minus x square. So given this displacement, x equal to negative 2.5 centimeter. Remember, be careful with the unit. centimeter. This one you're going to put centimeter. So your amplitude also in centimeter, isn't it? Your amplitude is, yeah, of course, your amplitude also in centimeter. Your amplitude is 4 cm. You follow the displacement. This is 4 cm. X is cm. So when the x is in cm, the amplitude also in cm. When displacement in cm, amplitude also cm. Okay, so my amplitude is 4 centimeter. So substitute, omega is 2 pi. Omega is 2 pi. Okay. Plus minus omega is 2 pi. And my amplitude is 4 centimeter. My x is, what is my x? Negative 2.5 centimeter also. Okay. So what is the velocity? Let's calculate. I got the answer is plus minus 19.62. What's the unit? Because it's follow the centimeter, right? Displacement is centimeter. So velocity also centimeter per second. That's the answer. Is that correct? Yes. Velocity is positive negative 1962 centimeter per second. That's correct. Okay. So that's how we do it. Yeah. Given time, you use the time. Given displacement, you use the displacement. Velocity time, acceleration time, velocity displacement equation. And learn how to differentiate displacement versus time, you get velocity. Differentiate the velocity time, you get acceleration. Okay, so that's all for, and the velocity unit, acceleration unit always follow the displacement. If displacement is centimeter, the velocity also centimeter per second, acceleration also centimeter per second square. Okay, so that's it. Thank you. Bye.